because usually you hear us in Polish speaking about SimCenter simulation and testing solution. But today we prepared some information to you according to predictive performance engineering solutions for agricultural equipment industry with specialists from Siemens software solutions. With me, there's Abdul, Lucia from Siemens, and Julian from EC Test Systems. And my name is Jacek, and I'm responsible for Siemens simulation and test solution in EC Test Systems Poland. Witamy Państwa. Dzisiaj może troszkę inaczej niż zwykle po angielsku, ale są z nami specjaliści z firmy Siemens i razem z nimi zaprezentujemy innowacje projektowe w sektorze maszyn rolniczych. Z nami są prezentanci również z firmy Siemens, Abdul, Lucia, ale też kolega Julian Osłuch, który jest u nas specjalistą od obliczeń numerycznych, i ja nazywam się Jacek Spisak i odpowiadam za dział związany z obliczeniami, z oprogramowaniem symulacyjnym i z pomiarami w EC Test Systems. So Abdul, maybe you can start your presentation so we can see how it look like and what we can do in agricultural industry today with Siemens.
Fantastic. Thank you very much. Okay. Hello and good morning, everyone. First of all, I would like to thank you all for attending today's webinar, which is about predictive engineering solution related to heavy industries, in particular agricultural equipment. During this session, we will uncover how engineers can discover better designs faster. In other words, how you can drive product innovation and gain superior productivity in order to be competitive in the marketplace. As Jacob introduced, my name is Abdul Ludi. I'm the EMEA Portfolio Development Executive responsible for SimCenter portfolio, located at Siemens office in London. The webinar will also be conducted by a number of speakers. We will hear from Lucia Scalafani, who is the pre-sales technical specialist located in Rome, Italy. And obviously, of course, we will hear from our colleagues from EC Test, our partner team. So let's start with a brief look at the agenda. We will start off with looking at the industry trends, challenges, and Siemens solution to performance engineering. This will be followed by some customer success stories. We will then have a live demonstration of our solutions in 3 areas. First, thermofluid simulation, then structural integrity simulation, and last but not least, system simulation. Now, before we start talking about the key trends and challenges the industrial machinery are facing today, let's take a look at the Siemens corporate video on SimCenter for predictive performance engineering, which is driven by integrated design solutions.
Get quantitative feedback on design performance, resulting in rapid innovation and reduced. The heavy equipment industry is faced with bringing smarter, safer, connected, and more sustainable products to the market faster. You can no longer afford to use slow, iterative product design cycles with isolated tools and processes that waste time in delivering the advanced equipment that's needed now. To accurately predict equipment performance right the first time, you need an integrated next-generation design solution that enables you to utilize real-world physics simulation, seamless CAE automation, and integrated real-time field data analytics, resulting in improved reliability, shorter development times, and lower project costs. Harvest the fruits of rapid innovation with Siemens Predictive Performance Engineering. Real-world physics simulation enables you to accurately predict equipment behavior using industry-specific scenarios in a wide variety of harsh environments to validate even the most complex autonomous equipment and operations more reliably. Seamless CAE automation enables you to do more simulation faster with automated processes and immediate quantitative feedback on design performance, resulting in rapid innovation and reduced overall costs. Integrated field data analytics bring real-time operational data into a closed-loop system of product development and maintenance to bring products to market faster that meet customer needs and embrace new disruptive trends. Reliably develop equipment right the first time and harvest the fruits of rapid innovation with Siemens Predictive Performance Engineering. Siemens, where today meets tomorrow.
Okay, Jacob, if you let me know if you can see the presentation slide again.
I think you need to stop presenting the video. And,
okay. And then I'll share the...
And I can see your screen now. Yeah.
Excellent. John, we'll start with the... Yeah, I can hear some echoes. Okay, great. John Deere, you may have maybe aware of this name, who developed the first commercially successful self-scoring steel plow in 1837. When he was asked about the first plow before it was tested, he said, well, I wouldn't want to make a sure promise before I knew I could perform. Now, 184 years later, one could say that the heavy equipment manufacturing shared Mr. Deere's feeling. No one wants to make a promise to customers that they can't keep. Yeah. What if you could better predict how machine will behave in the real world? The promise are kept. We know the world is evolving. Yeah. The heavy equipment industry in general is divided into three parts: agricultural, construction, and mining. The size of the agricultural equipment market was about 150 billion globally last year. This is expected to rise significantly. One estimate suggests to around 230 billion in the near future. The agricultural industry commits around 19% of the greenhouse gas emission globally, which is a significant amount. Therefore, like the automotive industry, as part of the Paris Agreement, there is a huge focus and major industry players make global effort to reduce greenhouse gases. Electrification is also playing a huge role in helping OEMs to meet the regulation. However, we want to be able to design smarter, be quicker to market, and provide the end customer with a product that they are going to purchase. As may be expected of an industry dealing with large and complex machinery, the heavy equipment industry is heavily regulated. So let's have a brief look at some of those regulations that are driving the heavy equipment industry today. First, the world population growth, a key factor that drives the agriculture sub-industry, responsible for supplying enough food to the world. Population growth also drives the increase in the demand for infrastructures and materials to build. Heavy equipment industry business has seen a slowdown during the COVID crisis, but not as strong as other industries, just because people need to be fed. A skilled labor shortage is often mentioned as a limiting factor to the growing supply expectations, putting high expectations on the machine to be more productive and less dependent on the support of the operator. Now, there are two implications for the industry. Supply the market with more productive systems that can follow the demand requirements and even take the lead on the operator towards optimizing field management. Also find better solutions that optimize ground exploitations. A second industry driver you can read about everywhere is the work done by institutions and governments to strengthen regulations towards the reduction of machine emissions. European stage 5 emission limits are more and more stringent. And as major cities move towards creating zero emission zones, companies will need to deploy zero emissions and less noisy machine to perform their work. Again, there are two implications for this industry with respect to this. Cascade down these requirements to drive engineering towards more sustainable powertrains and energy sources like hydrogen-based or electric-based technologies. Still, the operator remains at the center of these regulations, as OEMs need to comply also with noise and vibration standards. And last, as the material demand increases globally, the heavy equipment industry is pushing ground exploration even further every day. This heavy equipment always encounter more challenging operating conditions specific to the region where the machine operates, each with tailored requirements. This last trend implies that the engineering department needs to guarantee that the existing machine design and the future design, including maybe an alternative power source, will be reliable, durable, and deployed anywhere in the world. Finally, even if the market globalization brings opportunities for business growth, the increase of regional requirements, customer tailored requirements, as well as the increase of powertrain alternatives, make system adaptability a real challenge for the industry, OEMs, and suppliers. All these trends, whether it's population growth, stringent regulations, or operating in variable environment, these respective implications are shaping the heavy equipment industry. And so it impacts the engineering departments of all key industry players from the 4 sub-industries, which are agriculture, construction, mining, and material handling. In today's webinar, we will mainly focus on the agricultural machinery. So when we discuss with our customers, try to better understand their difficulties, most of them, they usually express the high pace set by regulation to explore design alternatives, which are performant enough to comply with regulation requirements. And so their need for tools or process to prepare for such certification. Then the need to collect realistic data in order to define relevant requirements based on realistic operating conditions, and so drive the system engineering workflow towards tailored machine performances ready for the field. And usually they express the difficulty to balance all these performance requirements when it comes to machine integration. Here is a testimony from ECHO supporting the fact that the acquisition of realistic data is a key element of their development cycle. According to a survey carried out by a market research group, level of customization is among the top differentiating factors that stand out in the market. There are quite a few implications for supporting greater customization. It drives the need for much better oversight of customer requirements. There are few opportunities to reuse earlier designs, and it becomes more challenging to meet time to market commitments. Increasingly, to be successful with customizations and be able to give what the customers want becomes an area where OEMs want to differentiate. Being able to design the product to be configurable from our customers or dealers will equate to better success. Increased level of customization means increased level of complexity. So how to manage such complexity engineering requirements and accelerate deliver of innovative systems to answer them, while putting the same effort on the delivery of steel compliant and performance machines. And yet, how to turn explosion of design complexity into a competitive advantage. To stand out in the marketplace, these are the questions that need tackling. And you can see on the screen how to manufacture, access meaningful data matching with field requirements at the earliest during the program. Then the how to manufacture, navigate the design space and validate a design maximum in a minimal amount of time and at a minimal cost. How do manufacturers drive the complex integration of technologies with customer requirements to deliver a high performance machine? Answering these questions requires solutions that can help predict and improve performance. This is what brings the digital twin at the center of Siemens' proposition. Hence, we consider simulation and test as the beating heart of the digital twin as a support of the performance engineering. Our integrated SimCenter simulation and test solution allow you to embrace complexity by deploying a digital twin to simplify the virtual design exploration and verification process, leading to a faster and cost-effective validation of the machine performance in harsh conditions. Centered around the digital twin concept, our solution for simulation includes system simulation, 3D multibody, and computational fluid dynamics, as well as specific domain-oriented simulation capabilities for battery, electromachine, or electronic components. It provides heavy machinery engineering teams with necessary capability for cost-effective design exploration, multi-attribute performance prediction, and control validation and verifications. The SimCenter portfolio simplifies the integration across the system layers due to seamless connection between domain simulation disciplines from system to part designs. SimCenter portfolio enables engineers improve their design confidence and get the right design first time. In order to achieve this, engineers need to perform advanced multiphysics and co-simulate to understand the cause of effects of real-world scenarios. Looking back a decade ago, very few companies could afford the time and effort to perform these type of simulation. Today, it is expected due diligence is being performed early in the design phase. Fortunately, with Siemens' integrated software portfolio, these type of simulations are easier to perform. Looking at the traditional computer-aided engineering process, the bulk of the effort is seen during the initial creation of preparation of models for analysis. It isn't until the models have been analyzed, the engineer doesn't know if the design is under, over, or adequately designed. If changes are needed, information needs to be shared back to the engineer for model updates. Then the model needs to be prepared again for the next iteration of the analysis. This process will continue until there is enough confidence with the design to move forward. SimCenter solution workflow empowers the engineers to understand how these design will perform sooner and allow them to make design improvements before the detailed simulation. This will vastly reduce the design process. In addition to doing more sooner, having tightly integrated software allows design and simulation engineers to improve the geometry and rerun analysis without the need of repeat unnecessary steps. Here we have a customer who have been able to reduce their project costs for optimizing emergency braking for grape harvesters by 25% with Siemens integrated solutions. According to a technical director, Siemens SimCenter enabled New Holland to save several months of engineering as they worked on the safety optimizations. SimCenter solutions integrates multiple simulation domains together into a single environment and a common model that enables seamless transfer of data between solutions. This streamlines the process of performing multi-physics simulations to more accurately predict performance under real conditions. Now let's now look at some customer success stories who have, those who have greatly benefited with Siemens integrated design solutions. And we'll start off with another customer success story. So I'll just move to the presentation mode here.
My challenge is to optimize our machines. I am calculating the motion behavior of our machines, especially from the crop protection sprayer and its sprayer boom, because the motion of the sprayer boom influences the accuracy of the sprayer, and that's why it's so important to know how it moves and to optimize it. We can reduce time and costs because we can reduce the time to develop a machine, and we also can reduce money because we can reduce the prototypes. We don't need as much prototypes as before. We also have a better view to our machines. We can understand them much better. You can watch to several points in the machine you can't see on the field. You can measure much more than in reality on the field. So there are many benefits for us. So in the future, I think our machines have to be more efficient and perhaps a bit bigger. But we need to also to automate and electrify our machines. So that's where we use the Siemens products to get better machines and to make them more efficient for our customers.
Okay. Here is another customer success from ECCO, a global leader in the design, manufacture, and distribution of agricultural equipment. ECCO used SimCenter Star CCM Plus for SimCenter portfolio to explore the design space to redesign an air redirecting device called FanStrode with the purpose of increasing the efficiency of the engine cooling fan. The fan shroud directs the cool air from the fan directly at the radiator, as well as it helps to reduce previously heated air from circulating back through the radiator, resulting in optimal performance of the cooling fan. By exploring the design space, ECCO was able to completely redesign the fan to circulate enough air through the radiator to keep the engine cool, significantly reducing the peak temperature in the engine compartment. Again, this is a great example of value one should strive to achieve with simulation. CNH Industrial is a customer of Siemens. They're also a global leader in wide variety of vehicles, from agriculture to construction equipment. They've been witness to change in the industry where 10 years ago it was more just curiosity. To the past few years, simulation is helping CNH design products which meet and exceed their requirements. Before CFD, CNH had no choice to rely on experimental testing and process of trial and errors. The success relied heavily on the experience of their engineering teams. Using simulation, they were able to design, build high-quality machine. The cost of making a wrong decision would only be exposed by testing. Later in the design cycle, which was a very high cost. By working with SimCenter simulation and testing solutions together, CNH were able to reduce their time to market and cost, while enabling to bring new innovation ideas to push new frontiers of commercial vehicle design. Over the past decade, CFD simulation at CNH has evolved from being an interesting curiosity to occupying central role in the commercial vehicle development process. Michalak, using SimCenter, were able to develop world first fully electric wheeled excavator. They were able to design accurately sized battery, perform battery aging analysis. According to their R&D, SimCenter allowed us to proactively explore new innovative designs. With that, I will pass the presentation to my colleague, Lucia, who will present on thermofluid simulation with SimCenter CFD.
Okay, thank you, Abdul. Just let me check how to do in the presenter mode. Sharing. Can you hear me? Can you hear me?
Yes, Lucia, we can hear you.
Okay, great. And let me know if you can see my screen now.
Yeah, sure.
Okay, great. Okay, thanks, Abdul. I'm, as Abdul already said, I'm a colleague from him from Italy, and from my side, I will present. I will talk about thermal and fluid part with SimCenter solution in the portfolio from Siemens. Let's have a look, a general look. Sorry, it's not going back to what you can do when we talk about thermal and fluid solution. You have an integrated platform, multi-physics platform, in which you can do a lot of kind of simulation. Here there are some snapshots just to give you an initial idea. So let's start from the classic one on the top left, that is the one in which you study what's happening inside the underwood. So to check if you have any peak temperature that should be avoided, for example, because it's too high for your material. Just on the bottom left, you have a classical slide plan to show which is the distribution of air and temperature inside your underwood. Also in this case, to check the maximum temperature, the recirculation zone, and so on. Just on the right, on the bottom, in the center of these images, of the snapshot, you have just a distribution of air inside your underwood and around your tractor. But thermal fluid, it does not mean only solids and fluid. You can do more. You can do multi-physics. An example is the image in the center, the top center, in which you are simulating distribution of the oil inside the gearbox. Or just on the right, you can study how your tractor can dig the material that he has to use to study every kind of interaction, and if it's the correct material, the correct motion, and so on. So we talk about thermal and fluid, but the platform that you can use is integrated for much more kind of simulation. And we are not losing on complexity. It means just looking on the small video on the right bottom, what you are going to simulate, your domain will be exactly the physical domain, just to avoid to lose any information during your CFD analysis. But let's go a little bit deeper into what you need to do for what we call a CFD simulation, so a computational fluid dynamics simulation. For every kind of CFD simulation, there are 4 main steps to do. Obviously, you need your geometry. In my experience, the geometry for so complex stuff is done into the company CAD. So we are talking about complex geometry that you can import inside the thermal and fluid solution from the Siemens portfolio. And then from this geometry, imported geometry, what you have to obtain is the generation of what we call volume mesh. It means you have to split your domain in small cells to allow the program to do its calculation for each cells and give you the results. The third step is to define which kind of physics you want to simulate. So if you are simulating air, water, solids, and so on, and define the boundary conditions. So how your domain is talking with the external part in the border. And last but not least, obviously, after the runtime, you will have the results. So you have the insight of what's happening inside your domain. And we can talk here, if I'm not wrong, there is an example of how the air is going inside the cabin, to have an idea if you have peaks of velocity, peak of temperature, and so on, recirculation zone. And we will see that you set your first simulation, then your second one, third, or 101 will be easier and easier. We talk about template. So you set your first simulation, then the next one will be easier and easier and quicker. Let's have a look to an example. In this case, we are talking about cabin comfort. And just to give you an idea of the complexity of the geometry, I took just 2 snapshots. This is the initial geometry. And for the CFD, what you need to do is to close all these surfaces that are coming from the CAD to obtain at the end your volume mesh. Also in this case, so to reach from the first step to the second step, everything is automatic. So there is an automatic closure that avoid manual repair, manual work, but in few minutes, okay, if it's really complex, 15 minutes, you go from a really high number of what we call errors, but are not errors, it's just the industrial geometry, to the CFD geometry, obtaining your volume mesh. That is the starting point for the calculation. In this short video, I show you a little bit which is the platform in which that Siemens used to give you a solution for the CFD analysis. Everything is integrated in a single platform. So here on the left, you have a tree in which you start from the import of geometry, giving all the instruction. Then you have also the post-processing and so on. So everything is inside the same graphic platform. Just to give you an idea of the complexity, I opened the same scene of before, but with different color. You see that here you have both the cabin and the underwood. In this example, the idea is to study the thermal comfort. So we will transform into domain of calculation, so into the volume mesh, the part of the cabin. How can I go from the complete factor to my domain, the computational domain? I just close it with what we call wrapper, and then I give some instruction for the generation of the volume mesh. But as you can see, it's really few settings to do because everything is automatically done. And the results for the volume mesh is this one. So let's say a short setting for the dimension of these cells, then you can push asking for the generation of volume mesh, and it's done. Consider that, so we have seen geometry, then we have the volume mesh. Now we have to set the third part. So we have to say to the software which kind of physics we want to simulate. Here there is, for example, the definition of the boundary condition. So which from where and which is the velocity that is entering inside your cabin. And then you have to define the physics. Okay, something is entering in your cabin. Is it water? Is it air? So you have to decide the model of physics that you want to simulate. Here is a steady state simulation. So you're looking for the equilibrium. The temperature equation is on because you want to study also the temperature inside. And it is a turbulence model with the right, let's say, low on the near the walls. When you have select the physics, everything is ready, and you can, like here on the top, where there is arrow, you can run and obtain your results. So this is the complete workflow that you need to do for your CFD simulation. To have a look at the results, what I have done is just to give. I did some slides, but it's in the same platform. Okay, just to open a new scenes. Here I put an example for the velocity magnitude, as we have seen at the beginning. So you study from the inlet, you set which is the initial velocity, and you study where the air is going. So if it makes sense to have different positioning, or if you have a recirculation zone, or if you have a peak of velocity that can disturb the driver. Or here another example, there are slices of the domain to check which is the temperature inside the cabin. Also in this case, we can talk about cabin comfort, because if you have too high temperature near the driver, it's something that maybe has to be optimized before going to production. So in this small video, we have seen which is the platform, and you have seen that the initial geometry was the complete tractor, the cabin and the underwood, so the complete geometry of your machine. But we transformed into domain only the cabin for the thermal comfort. But with the same case, we can do also the external aerodynamic, for example, studying what happens inside the underwood. So here there is just few images of an external aerodynamic in which you have a boundary condition that gives the velocity of the air that is coming inside your domain. So the domain this time is the external air of the machine plus the domain inside the underwood. So you have your velocity, and you can see with the post-processing, which is the distribution of air and temperature. And what happens if you change the value of velocity of the angle of velocity that is coming in your domain? Obviously, also the results and this distribution is changing. Here, a third example, just to say this kind of external and study and maps of the underwood, the distribution, temperature, and velocity is what we call a steady state simulation. So it's really a quick simulation to give you a good insight, and it allows to you to do more than one condition. But what happens if you want to study in time, so second by second, what is the situation inside your underwood? You can start using the transient simulation. So something that is a little more as a higher requirement for your hardware, but gives you step by step, step by time step, the real situation. So here it's a real example that has been done for an underwood, in which the goal of the simulation was to study for some materials, for some device, the peak, the temperature peaks, to avoid any trouble or issue in the real life. And so to have the possibility or to change the material or to change the position of the device. Another example, so we have seen the workflow, we have seen that cabin comfort and external aerodynamic can be done in the same platform. And you can do more, and what you can do is to ask to the software to improve the geometry or the boundary condition, to give you a better results. Here there is an example for the fan noise. So it's a fan for an underhood, in this case for a car, if I'm not wrong. And the setting for the software was, okay, this is my initial geometry. You can change a parameter of the shroud of this system. Please find the right shape to decrease the noise of this device. And this kind of simulation are done in an automatic way. So you set your first simulation, as we have seen in the workflow, you set your goals, and at the end of these optimization studies, they obtained a reduction of the sound power and also an increasing of the mass flow of the fan. So, giving you a summary of what we have seen together. So, sorry, from the baseline design to the best design. So it changed the shape of the shroud. We have seen cabin comfort study. So everything is inside one platform. So you can go from CAD to post-processing, and you have with this kind of simulation. For the cabin comfort, we talk about steady simulation, but obviously you can do also transient also in the cabin comfort. You have the extra insight for what happens in your domain. The workflow, you need to set the workflow once, then you can do more and more tests. Pardon. With the same platform, you can do different simulation like external aero, underhood study, and noise reduction, and so on. And last but not least, you can do your single workflow, but you can increase your efficiency in an automatic way, asking for more and more simulation to reach a better performance of your design. Okay, and this is a quick summary of what you can do with the platform inside the Siemens portfolio. And if I would pass the ball to my colleague from EC Test for the part of the FEM, okay?
Okay, thank you, Lucia. Very nice summary of what you can do in CC and BAS. So now I will present from our side the structural simulations and system simulations. So I will only share my screen. Okay. And okay, so we can start from the structural simulation, but taking into account the solution we have in SimCenter 3D solution, you can make also different simulation, starting from structural static simulation, structural dynamic simulation, going to even multi-physics simulation, taking into account acoustics, taking into account flow simulation. So you can do many simulation in 3D domain. Also you can taking into account acoustic. You can do it with finite element method. You can do it with boundary element method. So there are many solvers closed in the one solution, which has got the one interface, which is also good and friendly for, I would say, CAD users. I would say it is very friendly for mechanical engineers who know how to use, for example, CAD solutions. And I will show it in my example. So you can see like acoustic simulation, like multi-body simulation connected with results from dynamic finite element method simulation, dynamic simulations, and all of this you can do in the one solution in one software. You don't have to export your results to another software. You can do it in the one friendly environment. This environment is based on NX solution, which could be known by many of designers. So I will show the simple example how to make a simple structural simulation in SimCenter 3D, taking into account that we don't have got the full model with the full history. We've got only IGS or step files, and we need to get results from the simulation very fast, and we want to do some changes very fast. So we will go from the whole tractor model you saw also on the Shia presentation to the finite element model of the ladder. We'll simplify it a little bit, and then we'll edit it to get proper displacement result and stress result. So maybe the first thing I would like to show very briefly is that you can simplify geometry for the simulation very fast and very kindly for user. If you're familiar with CAD solutions, you can work on this environment very intuitive. So, for example, you can see the step of the ladder, which could be edited to do a structural simulation very briefly. Of course, you don't need to simulate of the hedges of this step, so you can simplify it very fast and very briefly. As you see, there is a step file which was imported to the SimCenter. So you can work on the NX CAD files, solid edge CAD files, but you can also work on universal geometry files if you want to, and you can do direct changes in the design. So the solution for the pre-processing can be very wide used. And what you can see on a video, we'll prepare the mesh for this step and for the whole ladder. Of course, in this SimCenter solution, you can use 2D mesh to prepare the mesh. You can use 3D meshes. Also, you can use tetra meshes. You can sweep along, and of course, you got many options to go. Also, you can see all the loads and boundary conditions added. Of course, we need to fix the ladder to the side of the tractor, and we need to include all the contacts and the loading on the step. And then going to to results. We have got too high displacement and too high stress on the step. What was the result of simulation? So the point was to change the geometry very fast to see how the adding some reinforcement to the ladder will impact on the whole model. So we've added the reinforcement using some simple operations of cut capabilities in this solution, and then we meshed it already, but now we will export this mesh from the additional reinforcement to the solver. When we will export it to the solver, we will also take into account all the contacts with other elements, and then we will simply run up the second simulation. We did it with non-linear solver to take into account the pre-stresses of the bolts. And okay, now we'll maybe fasten it a little bit, maybe. Okay, you can see the reinforcement on the higher step, and then the boundary conditions. So I got this one on the bottom. I'm not sure if I can move it anywhere. Okay, so we'll create automatic phase parse. It is only also can be shown how to fast change boundary conditions in our model in SimCenter 3D. Okay. So all the changes in the mesh and in boundary conditions will be done, and we can simply clone the simulation. Maybe I can move it forward a little bit. I'm not sure. Okay, and then we clone the simulation, and we're gonna solve the simulation. Okay, and then we can simply in some few fast steps compare the results from the first model and the second model after some changes. So on the left, okay. Okay, on the left we have got like maximum stresses, maximum reduced stresses like on 170 megapascal, and we have got on the right like even okay for the okay. So you can see after some post processing 130 megapascal and 95 megapascal on the right after adding the reinforcement. So it can help us to do some optimization of our design, as Lucia earlier showed us the heat solution. Also, we can do optimization also with SimCenter 3D and with structural solutions, and we can have got very fast feedback for designer. We can do some very fast changes in the design, as you saw earlier. So that will be all for the structural simulation, and I will pass the presentation to Julian, who will show the system simulation. Okay.
Okay, hello. I'd like to introduce you Siemens solutions for modeling systems. Sim is software which allows you to create mechatronic systems just by connecting parts. Developers care about that software is focused on being user-friendly. It offers you more than 38 libraries, which contains different elements like hydraulics, pneumatics, thermal, mechanical, signals, electric, and many more. Sim also have a base of more than 6,000 models. They are ready to use, and you can introduce your own changes to them. You can modify them. The base of models are still updated, but if there's no model that you're looking for, EasyTest Systems offers creating new system models on demand of customer. We can build a model for you that you need and also teach you how to use and develop simulation further by yourself. I'd like to tell something about the way of creating models in SimCenter solutions. The main advantage of this solution is that the user don't have to know mathematics at high level, and everything you need to create your own models is to know physical phenomena that you want to simulate. It's the quickest way and most accurate to build simulations. Additionally, you don't need to create any differential equations by your own. You just connect elements and input values of parameters. Also, what is worth taking into account, you don't need to spend time on making a geometry. You just input coordinates of elements, and every changes that you want to introduce are really fast. And now I'd like to show you the example of use of Sim simulation. I choose something from agricultural equipment industry. Here is the tractor with a flag. And here is shown how to model the system of the plow. The model contains elements from 2D mechanical library. There are arms connected by pivot joints. Now, here is the part made of hydraulics elements, and here is implemented the control of system. We used their elements from signal library. And now I'd like to show you the results of simulation. This is animation where we can see if everything is working correctly. And it shows the move of the mechanism. And yeah, machine simulation have also really intuitive solutions to post-process your data and visualize results from the simulation. For example, here is the plot of pressure at one of the parts of hydraulic actuator. And on the bottom, there is input that is steering our mechanism. Yeah, and here's the model in the software. Making changes in AmaSim is really intuitive and simple. You just input your own parameters. For example, here are properties of our hydraulic fluid. There are some fluids also in the library. You can choose them. One of them, or create your own fluid with your own properties. Here are the geometrical properties of the cylinder, like piston diameter, rod diameter, and here's shown how easy to implement, introduce geometrical properties of elements. Yes, and that's it. I hope this short movie showed you that simulating your mechatronic systems in AmaSim is really easy. And yeah, that's it. Thank you for your attention.
Okay, thank you very much, Julian. So, if you have got any questions for us, according to examples you saw, any questions to Abdul, any questions to Lucia, please feel free to ask. I can give you a permission to use a microphone if you want. Only give me any information on a chat, or you can chat your question. Zachęcam Państwa do zadawania pytań. Dziękuję bardzo wszystkim prezenterom. And of course, if you want to go deep in these solutions, in StarCCM solution, in some CFD solutions, structural solution, system simulation solutions, we'll provide some workshop also in some time. Of course, the video will be we will share the video from this webinar with you. And if you want to go deep in any of these solutions, CFD solutions, structural solutions, mechatronic solutions, you can feel free to ask. I will also share a short survey with you. You can give us a summary after our presentation. you can, in the last, I think, open question, you can ask about some presentations you would like we to prepare for you, or you can ask about to contact you with these solutions and to go deep to have some more knowledge about these solutions we have presented. Can you
I just wanted, yeah, can you hear me, Jacob?
yeah.
I just wanted to add, I think, yes, we have presented a lot of things today. We focused on area of computational fluid dynamics, structure, and also system simulation, as well as optimization of all those areas with SimCenter portfolio. We've covered a number of areas. Do let us know which area that you would like, as my colleague here said, they would like to go deeper and to understand how our solution can help you in the area that you are interested in. So certainly we'll be keen to hear more from you. There will be, as my colleague announced, there will be a workshop live, so you could join in. You could trial the software, or more than one solutions on the day. What we call it a test drive workshop. So you get to speak to our colleagues with expertise on our solutions. You can discuss any problems or bottleneck or in your current process, and how we can help to optimize and solve any issues you may have. We're here to help you. I mean, this is one of the things we do at Siemens. We build relationship with our customers, close relationship with our customers, to help them in their process to be more innovative, efficient, and productive, and that they can go on to gain market competitiveness. So we look forward to hear from you, our partner at Systems. Yeah. If you do have any questions, I mean, you feel free to ask us here now. If not, then you could surely contact our colleagues at EC Test Systems, and then we will, of course, look into those and be in touch with you as soon as possible.
Thank you, Abdul. Yeah, I think we can give 3 additional minutes for some questions and for survey to be completed.
I just want to make one additional comment to our audience here, is that EC Test Systems work very closely with Siemens AG and Siemens Simulation and Test Division. We work very closely with our partner here to serve our customers. So if any customers in Poland, if they have any issues and they need support, they immediately contact our partner there, and if they needed further support, they contact Siemens immediately. So we have a big team behind our partner team to support them. So our customers never sit there on their own trying to understand how they can solve that problem. We take that headache from them and try to help them, make it easy for them, so they can spend more time doing design rather than trying to solve the problem. So we are there always to support our partner and more importantly, our customers, wherever they are.
Yeah, great summary, Abdul. Yeah, if there are any questions, you can type in chat, or you can ask in survey. So we will contact you after the webinar. So jeśli Państwo mają jakieś pytania, można po polsku. Też jeśli są pytania do Abdula albo do Lucy, postaram się przetłumaczyć. Można też zadać pytania w ankiecie, albo zachęcam do wypełnienia ankiety. Widzę, że już prawie połowa z Państwa wypełniła. Okay, if there are any questions in Polish, I can translate as I said, but I can't see any questions now for Lucia. Lucia is a great specialist in CFD simulation. Abdul has got knowledge about all Sim Center portfolio products, so you can ask here if you would like to have got instant and fast response. Okay, I think the time is up. So if I hope to see some of attendees on the workshop in the future, because we'll organize free workshop on the software, so you can try to, for example, solve your problem, check if you can solve your problem in with our CFD system simulations or structural simulation solutions.
While we may have a few more seconds before we close the session, I would say is the solution that we have, and as we mentioned, they are very much integrated solutions. So, you may work on one area of the solution domain, whether computational fluid dynamics or structure. But if you need to integrate data from one of those solutions with the more system-related solutions or system simulation, it's much easier. You can add data and immediately build the entire 1D solution. And the same applies with all our solutions. It's highly automated, very easy to use, and the main focus to engineers is to be able to focus on design solution, being able to get to their final solution as fast as possible through our vertical solution, as well as the optimization solution that we have. It's a game changer for customers in the industry. So we look forward to seeing those who are interested to try out the solutions at the upcoming workshop. Yeah.
Okay, so I think we can finish the session. So thank you, Lucia. Thank you, Abdul. Thank you, Julian.
Thank you to you, to all, for the attention.
Yeah. Thank you, and thank finally to all those who attended today, and all the best, and have a good day.
Yeah.
Bye bye.
Bye for now.